Hello everyone and welcome to my paper. My name is Joy Bose and I'm currently working at Ericsson Gaia, but the work which I did before this was on this paper is based was in Microsoft when I was working there. The title of my paper is Intelligent and Secure Autofill System in Web Browsers. Let me go through the problem statement and how we work through it. So the problem is as follows. There is a feature called autofill, which you must have experienced in web browsers. Like nowadays, it's in every web browser, whether you use Chrome or Firefox or um, Microsoft Edge or any other web browser. So the thing is that when you go to a form, a web form, such as even a login page like Yahoo login or Google login, Gmail, or any kind of form, you will probably see fields like name, username, address, email, bank details, things like that. So sometimes the browser itself stores your information and it is automatically filled. Like you get like a pop-up like here, which kind of says where the name is whatever previously you must have filled in the name in some other form, it automatically shows that name. And you have of course the option of editing your autofill solution. You may not agree with whatever it's trying to fill, so you can just use backspace and use some other value. But it stores this information and it is filled automatically in web forms. So what we want to do in this paper is to develop a scalable, accurate, and secure system for this autofill feature. Autofill feature is already there; that's not new, but it is not using ML solution and it is not secure enough, as I will show you in a few slides. So how do we solve this autofill solution? So there's one approach can be like a naive approach or brute force approach, where you kind of store every single combination of the URL and the name of the field. If you look at the HTML source of that form, then you will see that there is a field name and some other HTML related to that form field, which is to be filled with autofill. So we can store this mapping of this is the URL and this is the field name, and what is the value that you have filled for that field name in that URL. So you basically store it and you store it in some internal database in the web browser. So the first time, of course, because the browser doesn't know what to fill, so there will be no autofill. But next time you come to the same form, because it knows that for this URL, this is the for this URL and for this field name, this is the value that should be filled. It just fills it. So this is very simple to implement. It just needs a database which stores this mapping everywhere. But it's not scalable because lots of fields, the name, for example, can be there in multiple forms, right? So you don't need to store the name separately for every single form. That is just not scalable. So if it will be better if it can learn some patterns out of this and not have to fill it separately for every form. So that is why it is not always useful, but it's still a good start. It's a brute force kind of approach. So another approach is the rules based approach where you kind of have a regex, a regular expression for the ID or the name or the label, and then you say that if this is ID or the name, then you fill it to a given value. So you use a combination of heuristic rules. So that is slightly better than the approach we saw before, because here you can use some rules. You can use a regex that if it says n star me or something like that, because all the forms if you look at the HTML will not use the exact same words. Some may say username, some may say name, some may say something else of different types, of course. So what is your name, something like that. So you can still make patterns and you can still identify what to fill in each case. So it is still easy to implement, but in some cases where the forms are dynamic, this will not work. Such a rules-based approach with heuristic rules will not work because the rules are fixed. And sometimes what happens is the rules are based on this is the name, this is the ID, and this is a label. But in dynamic forms, these things itself, the name or the label or the ID, may be dynamic. They may change with the time. So this will not work. So we come to a machine learning based approach, which can be easier to generalize and which will work better with dynamic web pages. That's the idea. So in the ML model, what we do is we take a number of web forms, you can what we did was we took Alexa 100 top 100 web forms in different categories and we extracted some features from it like URL, ID, HTML name from the forms. You look at the HTML of the form and we extract these features. Then you make a labeled training dataset. You do some basic preprocessing to make the features and then that's how you make the training dataset. And then you train a model based on some simple ML algorithm. It can be deep learning, it can be anything. So that learned model is then kept in the web server. So you make a kind of web service out of it. And while prediction, what happens is you have the web browser like Microsoft Edge or Chrome or anything. So the same way, in the web browser, you have a kind of a web extension which extracts these features and sends it. It's like a web service. So it sends it to the web server to that model, which is stored in the web server, and then the model replies the predicted label, and then that gives a prediction. That it identifies that if the name says what is your name, then that means it's a field called name. So whatever is stored in the name field in the web browser, that should be returned. So then it does the autofill. So this is just an example of a dataset for an email classifier. So if you see, we have just gone through multiple forms. This is not the full dataset, but it's part of it just to illustrate how it works. So for example, the label is like email, and it says email or mobile, or it says enter your email, or it says email or phone, this kind of thing. If you actually go to like multiple web pages, right, like Facebook's login and all, then you will see this kind of thing, or Yahoo sign up form and all that, even for bank sign up forms. And in this field called name, it says email or session key or reg mail like that. ID is this. So because we are looking at the email classifier, so actually what we had to do was we had to build multiple classifiers for each field. So separate machine learning model we had trained for email field, separate one for name field, separate one for age field, and so on. So this is the email classifier. So this last field gives one if it is actually email, and it gives a zero if it's not an email. So for example, if it says a mobile number or something like that, it will not be an email, so it gives a zero. And if it is an email, it will give a one. So something like that. So that is the email classifier part. So it will basically fill in one of these. Now, of course, you may have one question: what some of the forms actually have multiple fields in there, where it says email or mobile. So in this case, at the moment, it can only fill in one at a time. It cannot fill multiple ones at the moment. But we have to think of in future work how to get multiple kinds of labels as well for this classifier. So anyway, so this is what it is. There is the URL, there is the type, there is the ID and name and label. So there is the dataset which we formed. And then we used ML Studio, Azure ML Studio, which is quite a good, it's a drag and drop interface for machine learning, which is very good also because it creates a web service very easily. You just, you press a button, you select what machine learning model you want, what is the input data set, what is the accuracy parameters you want. Like, for example, you're trying to um, get the best precision, for example. In our case, we wanted best precision. So we put that parameter and the evaluation, how you do it and all that, and then it will give you with the results directly. And it also make a web service out of it. So you can keep that web service, it will give you the URL of the web service, the API and all, and then you call it from the web browser. That's Azure ML Studio, but we also can do it without using Azure ML as well. So the results which we got so far, we use a train test ratio of 70 to 30. We tried with a few different models: linear regression, support vector machine, Bayesian forest. And with Bayesian forest, we got 95% precision, which was highest we got. And these are the parameters we used. It doesn't mean that Bayesian forest is the best one. I mean, there maybe a deep learning model could have been better. We didn't try it at the moment. But this is the best result we got. Like 95% is quite good for an email classifier. And we had similar kind of 90 plus. 90 plus was our threshold for different kinds of classifiers. We had one for email, one for name, one for age, and a few others basically. So we had one model for each of the fields in the web. So that was the intelligent autofill part, where we used the ML model to predict the labels of the field. Another thing we also saw in the same paper is the secure autofill part, which is that sometimes in this autofill feature there may be some hidden fields. So some unscrupulous websites or web developers may have some hidden field where the div ID is set to hide or something. And what this does is it exploits the autofill, because autofill will directly fill all your name and things like that. So with hidden field which says credit card details or your address or your name, then it can get your personal details just by uh, from the autofill. You will not even see that part because it's hidden. That is the problem. So it's a hidden fields issue, and it's a known vulnerability. It's not fixed yet. So what we did for this is we created some rules. We just saw the patterns of how in some web pages this is actually an issue, like the pages where the field name is hidden, or the actual field in that form is hidden. So either it can be the CSS properties as visibility is hidden, input type can be hidden, or the style may be hidden. There are multiple ways in which hidden forms appear. So we made some rules based on that, and we use those rules only to guess whether it's a hidden field or not. And if that is the case, we disable autofill. That's the idea. So finally, to get a conclusion, we have two things in this paper. One is a machine learning based solution for intelligent autofill, which will just it's a classifier for email and name and age and so on. Multiple classifiers are there, and we have got it through a web service using Azure ML. Secure autofill, we have got a rules based approach to detect the hidden fields and then disable the autofill. So that is what we have got, and in future we'll try to make it work better. And we are also exploring another one. Instead of using Azure ML, we can use WebML with ONNX, which is just another technology which can do the same thing. It's just it'll be integrated with web browser. So Microsoft Edge, that was what we're working on, try to integrate it with the web browser instead of having a separate web service. The web service has plus and minus points as well. These are the references, including patent papers in this area, both security wise and ML wise. And finally, thanks for listening. And this is my contact. If you have any questions on this, or you want to even collaborate or do anything, you can please feel free to contact me. So thank you.